Now we're going to move on to geometric series. So a geometric series will take something of this form. So this is an example of a geometric series. We can rewrite this. We can rewrite this as this, because if you look at this, a half can be rewritten as a half to the power of 1. A quarter can be rewritten as a half to the power of 2. An eighth can be rewritten as a half to the power of 3. The whole point of a geometric series is that you've got a common ratio. You've got a common ratio. You've got a common ratio. The next one will be a r to the power of 3. You've got a common ratio. So here you've got a common ratio, but then each time it gets powered up by 1. So to the power of 2, to the power of 3, and so on. So the whole point of a geometric series is that you've got a common ratio here. You've got a common ratio. So in this case, for this sequence, the common ratio here would be a half, and the a here is actually 1 in this case. So this is an example of a geometric series because it's got a common ratio here, common ratio of a half. So here's another example. So a geometric series will be of this form, where you have a common ratio. You see, this is an example, another example of a geometric series. We can rewrite this as we can rewrite this even though the signs are alternating. You've got a minus, plus, minus, plus. We can push the minus into here, so we can rewrite this. We can rewrite this as negative a third to the power of 1. Negative a third to the power of 2, negative a third to the power of 3. So this is another example of a geometric series. In this case, the common ratio is negative a third, and again a here is 1. A equals 1 in this case. But the whole point of this video is, how do you go about summing up all the terms from 1 all the way to infinity? How do you sum up all the terms from 1 all the way to infinity? So rather than answering this specific question for r being a half, let's just look at the general case. Let's just say we want to sum up for a general case, for this case here. So the way we're going to do that is, rather than summing up from the first term all the way to infinity, let's just sum it up from the first term to some capital N, and then later on we can take the limit as n tends to infinity. So that's the idea. So we are going to attempt to sum up all the terms from the first one all the way to infinity, from the first one all the way to infinity. But rather than doing that, let's just sum it up from the first term to some arbitrary term, and then later on we can take the limit as capital N tends to infinity. So let's just try and sum it up from 1 to some arbitrary term. So that's us doing this. Sum it up from 1 to some arbitrary term. Remember from one of the earlier videos, we said that if you hang on, bear with me. From one of the earlier videos, we said that this is a notation we would use to sum up everything from the first term all the way to infinity. We would use this notation here. Let's say 3 here. That would mean us summing up the first 3 terms. So that would be us summing up the first 3 terms. So if we use this notation, S capital N, it really means us summing up from the first term all the way to some arbitrary capital N term. So this, for us to sum up from 1 to some arbitrary term, basically this thing here is the same as this. It's just a notation. This here is just a simpler way of writing this. So notice that this is exactly the same as this. So we're just changing the notation here, because it makes life a lot easier rather than having to rewrite this every time. So remember, this means us summing up to some arbitrary term here. So this here will be capital N here. So we're just going to sum up to some arbitrary term. So Sn would be us summing up all the way to some arbitrary term here. Okay, so hang on. So we were here. This is what we want to figure out all the way to infinity. But I will continue in the next video. Okay.